Let's think about investing in a combination of these two stocks where we have a certain amount of money and we put a certain percentage of that, let's call it 80%, into Kellogg, and then the rest, 1 minus that, into Exxon. Now since we typed in 80, I'll format that as an input, and we'll leave the other to appear as a formula. And so we want to know, how did the portfolio of those two stocks perform? And so if we had $100 and we put 80% into Kellogg, it'd just be that percentage times the return we got on Kellogg, which wasn't very good that year, plus whatever percent we put into ExxonMobil times the return we got that year on ExxonMobil, which was pretty good. And so that's the formula for the weighted average return on those two stocks. If we look at what that looks like each year, then we could also calculate the expected return going forward for such a portfolio and the standard deviation of such a portfolio. The real key thing to notice here is that while the expected return is, as we'd expect, it's between the two returns, it's better than the low return, but it's not as good as the high return. The real surprising thing is that the standard deviation is lower than either one. And so by allocating our money, putting our eggs in two different baskets, when Kellogg had a really bad year, Exxon had a great year. When Exxon had a bad year, Kellogg had a good year. And so while our expected returns are the same, the chances of being down on both stocks in any given year is not as great. And so we've received this portfolio effect. And so let's throw that onto our plot over here and see where that point would plot. Just extend these series a little bit. And we see a new point pop up right here. So I'd like to see what different combinations are possible. So this is a great deal. It's a better return than Kellogg at a lower risk, but it's not as good a return as ExxonMobil. So is this better than this? We don't really know yet. We'll get into that later. Let's change this weight in Kellogg to show how this middle point moves across all the different possibilities. We can show that even better by creating a data table that shows the percent in Kellogg varying from 0% to 100%, and seeing what the risk and return are. Now, since this graph is based on data that is in rows, and my data in the data table has to be in columns, I'm just going to copy this graph and change where the data is looking. And then we see the full envelope of outcomes as we vary the weights in our portfolio. And while I couldn't resist that opportunity to use a data table, it's not really needed here on our portfolio optimization work, so let's undo all that work. And now let's look at an analytical way to get to the same answer.